Well, let's get started. I'm really excited to talk to you all today, and I really thank you all for joining us. I'm Linda Tannenbaum, founder and CEO of Open Medicine Foundation and Open Medicine Foundation Canada. I'm sorry that I can't be there in person as I've done with our other worldwide tours, but actually with Zoom, we're able to reach so many more of you that this is actually a better way for us to give an overview of who we are and what we're doing and leading research and delivering hope and letting you know about all the things that we're doing. So I first want to give you a short overview of OMF and OMF Canada, and then have Dr. Christopher Armstrong, our science liaison, give you an overview of our research projects that we're currently funding. First, I'm thrilled to announce and introduce our OMF Canadian strategic partners, who many of you know, but some of you may not and may want to get in touch with them. We all want you to know that you are not alone. And I encourage you to reach out to these organizations by joining one or more of them. Since you've signed up to the webinar, we'll send you a link that you can refer to for their contact information afterwards. This first one is the National ME-FM Action Network, and they've been informing Canadians about ME and fibromyalgia since 1993. Among their many accomplishments is spearheading the development of diagnostic and treatment protocols for ME and FM, and published statistics on ME and FM, and wrote a guide on applying for disability and other educational issues. They published a quarterly newsletter, they translated key documents into French, they brought an international research conference to Canada, and supported the development of a complex chronic disease program in British Columbia, and also supported the development of the I-CAN-C ME Research Network. Millions Missing Canada advocates for treatment access, appropriate medical care, and equitable research funding for ME. Action CIND focuses on raising awareness, advancing research, developing education, providing information and support services for chronic immunological, neurological diseases. Action CIND. ME-FM Society of British Columbia, their mission is awareness raising, information sharing, education, advocacy, patient-oriented research, and phone and online support. And Manitoba ME-CFS Support Group, they have monthly support meetings and educational workshops. Please take the time to look up these great organizations as they are really there for you. I've had the pleasure of meeting some of you, and many of you know who we are, but briefly, for those of you that do not, I started Open Medicine Foundation, OMF, the parent foundation, in 2012. And we lead now the largest worldwide effort to fundraise and facilitate research to diagnose and treat and ultimately prevent ME/CFS and related chronic complex diseases, including fibromyalgia and post-treatment Lyme disease. We've raised over $28 million from private donors and facilitated and funded the establishment of 4 prestigious ME/CFS collaborative research centers. OMF Canada was launched in June of 2019. The ME/CFS Collaborative Research Center at Children's Hospital St. Justine at the University of Montreal kicked off in December 2019 with Dr. Alain Moreau as director. Dr. Moreau, as many of you know, has been researching ME/CFS for several years already. We wanted to give you the feel of the expanded OMF collaborations that we work with. The next few slides showing the founding members of each of our established centers, and you can see how large this effort is becoming and is growing. So this is the University of Montreal ME/CFS collaboration. As we said, we launched in 2019 with Director Dr. Alain Moreau. The Stanford ME/CFS collaboration we launched in 2014 as our very first collaborative effort, and the director is Dr. Ron Davis. The Harvard ME/CFS collaboration we launched in 2018, and it is with co-directors Dr. Ron Tompkins and Dr. Wenzhong Zhao. The Uppsala collaboration we started last year in 2019 with Director Dr. Jonas Bergquist. We have an 18-member scientific advisory board with 20 Nobel laureates and top world-renowned scientists, researchers, and clinicians that decide the most important research to fund. Now that we've established OMF Canada as an official charity, you will receive a tax donation for donations for OMF Canada. We have an OMF Canadian Board of Directors who approve and have oversight of the funding requests made by the OMF Scientific Advisory Board. According to the governing rules, OMF Canada can fund research in Canada and at Canadian government-approved universities worldwide, Harvard and Stanford being two of them. And we fund by way of our 4 collaborative research centers with recommendations from our scientific advisory board members that you see here. And now I'd like to introduce Dr. Christopher Armstrong, our science liaison, to give a pre-recorded overview of some of the projects that we have and that we're currently funding.
Hello everybody, I'm Dr. Chris Armstrong and I'm the science liaison for Open Medicine Foundation. I'm going to be giving an overview of the research project. Show this image, which is an overview of the research strategy that Open Medicine Foundation is employing. We like to show this image because it highlights that although there are many projects that Open Medicine Foundation is funding, it's important to note that all of them are somewhat aiming directionally to get down to this bottom right quadrant, which is to develop treatments for ME/CFS. It's important to show this image so that people can understand that while we're funding projects that are trying to create information or data on Open Medicine Foundation by looking at differences between healthy controls and ME/CFS or ME/CFS and other diseases, we're then using that information to define the pathogenesis and try and work out ways in which we can fund projects that are looking to develop hypotheses for this disease. We're also trying to fund projects that are looking to design diagnostics based on those biological differences that are found in the data exploration phase. If we were able to define the cause of ME/CFS, we'd be able to develop treatments that directly target that cause. And if we're able to develop or design diagnostics, then we'll be able to look at biological changes that occur during treatment trials, which would vastly improve the infrastructure for clinical trials into drugs with ME/CFS. And so both of these avenues will eventually lead to developing treatments for this disease. Also, at the center of this image, you can see that sample collection is a key part to this strategy, ensuring that we have standardized ways of defining ME/CFS, defining healthy controls, and using other diseases as comparisons, but also define specific ways in which we collect biofluids that are consistent, as well as creating surplus or biorepositories from excess biofluids that can be shared across the centers. The Open Medicine Foundation started funding collaborative centers with the Stanford Collaborative Research Center. This was funded several years ago, and the Severely Ill Patient Study was the first project to be funded by Open Medicine Foundation. This project is actually still ongoing. Researchers really like to use these samples because there's been so many tests done on these samples that there's a wealth of data that comes along with any of these samples we use for further studies. That means that researchers have access to this data, and any findings that they have or they can create or observe can be compared with other data on those same patient sets. The expansion of the ME/CFS Data Center at REDCap is an important tool for collaborative research across the centers. The data center allows the sharing of data, and REDCap allows the sharing of patient information and sort of patient registry that can be shared across the groups. Research for pathogens in the blood is an important study at Stanford. They've been developing great technology to be able to look for this within the blood. The nanoneedle is a device that has been shown to differentiate people with ME/CFS from healthy. There was a paper on this last year. Currently, they're testing other diseases at the moment and are testing potential treatments as well. Is something that's in the pipeline. Studying the flow and deformability of red blood cells in ME/CFS is also a project that Stanford has been conducting for a couple of years now. They're looking at the deformability of red blood cells, but also looking to determine the in vivo microcirculation and flow changes in ME/CFS patients. The metabolic trap is a very interesting hypothesis defined by Dr. Robert Fair. This is where they found IDO2 mutations from the severely ill patient study. And this was looking at differences in that data and was able to develop a hypothesis from that data surrounding the idea that elevated tryptophan in ME/CFS cells is inhibiting the only enzyme that can create kynurenine in that pathway, and that's somehow blocking the ability to create kynurenine and energy molecules. The nitrogen hypothesis is another study, or is another hypothesis that has been developed. That's actually developed by myself. That was incorporating data from previous work that I've been doing in the field of metabolomics for a number of years. And that hypothesis is based on the idea that using nitrogen-containing energy substrates to create energy, like amino acids, is exposing ME/CFS cells to high levels of toxic nitrogen-containing byproducts of energy metabolism. We're currently looking to do nitrogen flux studies to track where that nitrogen is going in these patient cells to determine if there is changes specific to ME/CFS, and explain some of the symptomatology of the disease. The Harvard collaboration was the second collaboration or the collaborative center that Open Medicine Foundation funded to initiate. This center has been going for a couple of years now. They're currently working on a number of projects. First of all, there is the work that's looking into post-exertional malaise. This will be done by looking at the skeletal muscle function in people with ME/CFS and comparing them to mobility match controls. And the way they'll be doing that is by looking for protein and metabolomic changes within the structures and functions of those muscles. It's also important to note that they have mobility match volunteers. This is to look really for sedentary controls, and no study has done that to date. It's an important feature that needs to be looked into to see whether healthy controls really are an appropriate control for understanding ME/CFS, or if there is confounding variables by having people with ME/CFS being quite sedentary compared to healthy controls who are a lot more mobile and active. Looking next is the study on plasma samples that were collected from invasive cardiopulmonary exercise testing in people with ME/CFS. And so those tests were run on people with ME/CFS by Dr. David Systrom. And those samples were collected before, during, and after the exercise. And the collaboration will be trying to look at proteomic and metabolomic changes within those samples over the exercise test and comparing them with healthy controls. The methadone treatment trial is also being conducted by Dr. David Systrom in collaboration with the center. The trial is to determine the efficacy of treating people with ME/CFS that have heart preload failure, and plasma samples will also be taken during this trial and characterized the same way above with proteomics and metabolomics. One of the important projects at the moment, and it's getting a lot of attention there at the Harvard ME/CFS collaboration, is the personalized automated symptom summary. This is the idea of using computer adaptive testing to develop a personalized diagnostic and treatment outcome tool for people with ME/CFS and other associated chronic diseases. And so the way that this works, this is a project that will be going on for a number of years. The way this works is by identifying or effectively fast-tracking the type of questions a doctor would ask a patient, but putting that into a computerized adaptive testing form so that you have leading questions that get to the root faster of a problem or a symptom and get quite descriptive with the patient interacting with it. And this can be done without a GP or primary GP being present, but it's something that we hope will create information for that GP to help them with diagnostics, but also helping them with monitoring ME/CFS patients and people with other associated chronic diseases long term. The last component that's taking a lot of focus in the Harvard ME/CFS collaboration is the establishment of rigorous clinical trial infrastructure. So REDCap is one component of that, but also the methadone trial is going to be something that's going to be helpful along the way in determining areas that may need enhancing to improve clinical trials. This Harvard collaboration is set up at the Massachusetts General Hospital, and their access to doing clinical trials there is already quite good. And this is something that they really want to get into more in the future. The Absolute University ME/CFS Collaborative Centre was set up last year with initiation from Open Medicine Foundation. But Open Medicine Foundation have been funding this this group at Uppsala for a number of years now, and they've been conducting studies for a number of years. Their focus is largely on the cerebral spinal fluid and the blood and looking for markers within both. They have a state-of-the-art suite of platforms, analytical platforms, that they can measure a number of proteins and metabolites on, and that's been largely their focus. So first of all, one of the main things they've been focusing on is developing less invasive sampling techniques for capturing cerebral spinal fluid, so that's the fluid around your brain and spinal cord, and also for blood collection. Things that make it less painful and for collection so that multiple collections can occur over time without adding too much stress to ME/CFS patients. They're also searching for neuroinflammatory markers to differentiate people with ME/CFS from people with other diseases. They've been working on a number of diseases in this lab for a long time, a lot of chronic illnesses and ones particularly related to neuroinflammation. And so this is something that they have a great deal of access to, and is going to be quite interesting to see how ME/CFS compares to these other diseases. They've also been focusing on autoantibodies creation and autoimmunity in a collaboration with Dr. Carmen Scheibenbergen in Germany. They're also looking to determine steroid or thyroid hormone changes in ME/CFS and looking at the regulation of these in ME/CFS patients. They're currently looking to also study herpes simplex encephalopathy to observe biological changes that are occurring in the development of ME/CFS after infection compared to those who return to baseline after infection. So these are severe cases of viral issues creating encephalopathy, and they'll be tracked over time to determine those who develop something like ME/CFS or long-term symptoms of fatigue, like a post-viral fatigue syndrome, and looking at how those biological changes differ from those that are healthy controls, or those who have the initial infection but then go on to recover normally. Finally, they're also doing a kynurenine treatment trial at this collaborative centre. This will be to study the efficacy of treating people with ME/CFS that have low kynurenine and cognitive problems. And this will be the first clinical trial that we're conducting there on ME/CFS. However, they have actually recently conducted a kynurenine trial to see the benefits of it on migraines. Finally, we have the last collaborative centre that Open Medicine Foundation initiated, and this one happened this year. The University of Montreal have a couple of studies ongoing that are funded by Open Medicine Foundation. These include the study of thrombospondin, and particularly in its relationship or hypothesis for the cause of ME/CFS, at least in a subset of patients. They're also looking to study the microRNA changes before and after a small stressor to better understand post-exertion malaise. At this time, we'd also like to talk about the multi-center collaborative projects that are occurring across all the centres. This is a key advantage that Open Medicine Foundation has created by funding these centres. They're also trying to encourage collaboration amongst them, and it is made quite easy by this foundation because there is access to funding to enable those sort of things to occur. And so the key project at the moment is this COVID-19 to ME research study. It's quite similar to what I described for the herpes simplex encephalopathy study at Uppsala University. This will be looking to track people who get an infection with COVID-19, who go to the ICU, and then looking at following them after they've left the ICU and over time to determine those who recover normally and those who get ME/CFS or other post-viral fatigue syndromes or complications down the track. By looking at the biological changes over time, these centres will be working together to identify trajectories or biological phenomena which may highlight differences based on the outcomes of their recoveries. And so this will highlight biological markers early on which may be predictive of outcomes and may also uncover the pathogenesis of diseases like ME/CFS, where recovery somehow takes a wrong turn. Thank you very much for your attention and listening to this presentation on the research that's being funded here at Open Medicine Foundation. Thanks.
I want to thank you all for joining us. I hope that you share our hope that research is continuing to move forward, even though we have this pandemic around us. We want and need to scale up these efforts and bring in more researchers and continue to move towards finding treatments. We need the whole world to engage in fundraising for this. And we ask all of you, our friends, to do whatever you can to get the word out about these diseases and help us speed up this urgent research. Thank you again, and may you all be safe and have improved health ahead. Until next time, bye for now.